So today we're going to be doing more with regression equations. We've already done regression equations one time. Today we're going to delve a little bit further into it. So I'm just going to star some of the parts that are a little bit different than what we've seen in the past. Today we're going to be talking about correlation coefficient. That's something new. We're going to be talking about how to paste equations into our y equals. So once we get the regression equation, we'll talk about how to paste it into our y equals. And the only other part that might be a little bit different than what we've done in the past is how to find x when you're given a particular y value. So, a couple new things. Let's start up here at the top with correlation coefficient. It says the correlation coefficient, denoted by r, is a number from -1 to 1 that measures how well a function fits a set of data pairs. When r is near 1, the points are going to lie really close to the regression equation that we get, the graph of the regression equation. And when r is near -1, the points are also going to lie really close to the regression equation. When r is near 0, though, the points do not lie close to the regression equation. There's going to be no correlation. You only need to turn on r once on your calculator, and if you turn it on once, it'll stay on. Okay, so I put a little box on how to turn on r. I'm going to go to second 0. 0, you can even see it says catalog. Okay, so I'm on my catalog. If you wanted to skip the second step, you could. You could just arrow down forever until you get to your D's. Okay, but I don't want to spend a lot of time doing that. So a shortcut is as soon as you press second 0, you actually don't even need to press alpha if you do second 0 and you directly click on D. So if I'm wanting to click on D, let's look at the top right-hand side of each button. Does everyone see how there's letters there in green? Where do you see D? Up here, right? X to the negative first, where it says matrix. Let's go ahead and press on that. See how it pops down to the D section? Now, let's say I did second 0 and I started to arrow down and then I decided I didn't want to keep arrowing down. Then you would have to press alpha D in order to get it to pop down. Okay, so. But it should default as soon as you press second 0. You should just be able to click D. You shouldn't even need alpha to jump ahead. Okay. So I'm going to arrow down to where it says diagnostic on. Press enter. And press enter again until it says done. That means that your correlation coefficient has been turned on. So when we go to calculate the regression equation, now it's going to tell us what the correlation coefficient is. They may need help getting their diagnostic turned on. Okay. Just briefly looking over this. Before you even start a regression problem, make sure that everything is cleared out of your y equals. Right now, if you look at my y equals, I've got a bunch of stuff in it. That's going to confuse you. You're going to press graph and you're going to be like, wait, I already have lines. No, it's not for this problem. It's for a previous example. Okay, so make sure you clear everything out before you start the problem. Okay. Then you would go into your stat edit and you would enter in all of your data. If your data does not show up on your graph, then there's two things you need to look at. One is the window setting. If you forgot to set a proper window, your data points aren't going to show up. The other thing you need to look at is whether or not you have your stat plot turned on. That's step 5, turn on your stat plot. Bless you. That's also something you only need to do once. Once you turn it on, it will stay on until you turn it off. I want you to feel comfortable turning it on and off. If you're doing a regression example, turn your stat plot on. If you're not doing a regression example, turn your stat plot off. Okay. Sometimes if you're not doing a regression example, you'll get an error message if you leave your stat plot on. Okay. So be comfortable turning it on and off. Okay. Once we get our window set right, we have our stat plot on, and we've got our data entered in, then we can calculate the regression equation. So that's when you're going to do stat calculate, regression equation. Make sure you're choosing the appropriate regression equation. If it's quadratic regression, make sure you use quadratic. If it's linear regression, make sure you choose linear regression. Okay? We've already talked about how to predict a y for a given x. The best way to do this is to, I think the best way to do this is to go to second trace, right? Second calculate, enter in your x value, press enter, and it'll give it your y value for the future prediction. Okay. Some common problems. If your graph doesn't look as expected, or if you get an error, make sure your window is adjusted. Typing zoom 6 sometimes can reset your window to a negative 10 to 10 screen and resolve your problem. Also, we're doing stat problems. So if you want to try to fit your data points into your window and you don't want to do it manually by adjusting the window yourself, does everyone see how there's a zoom stat? Zoom stat will try to take whatever data points you have in your table, and it will choose an appropriate window setting for you. Okay, so that's a nice shortcut. If you are someone that doesn't like to take the time to manually adjust your window, you can always try to do zoom stat first, and then if you need to adjust your window from there, you can. Okay, it's not always going to work. I mean, it's a calculator, right? So it'll do the best it can, but sometimes you'll need to use your logic skills to manually adjust the window as well. Okay, but that's an option. Okay, let's go ahead and go over to the back. This is the example we're going to do together. It says the data shows the per capita energy usage in billions of BTU, bless you, and the per capita gross national product in thousands of US dollars for a sample of countries. Okay, so basically the input is the energy usage. So that's your X values. And then the Y output is going to be the per capita gross national product. Just so we can understand what's going on here. Okay, so in this case, energy usage in millions is going to determine the gross national product in thousands of dollars. Part A says to use the regression capabilities on your calculator to find a linear model. Okay, so let's make sure we're using the right regression. We're doing linear regression, and it also wants to know what the correlation coefficient is. Okay, so let's go ahead and go to Stat Edit, and we're going to enter in our data. I'm going to arrow over and up, clear out my L1. Over and up, clear, enter. Clear out your L2. Okay. And you want to make sure that you're entering data as ordered pairs. So if this is the ordered pair 71 9.0, you want to enter in the ordered pair 71 9.0. 71, enter. 9.0, enter. See how they still go together? They're right next to each other in your L1, L2. Okay, so the next ordered pair is 48, 4.8. 48, 4.8. I have found that it's faster, for me at least, to type in all of my X values first into my L1 and then arrow over and type in all of my Y values into L2. You just have to make sure that you don't switch up your points. So you don't want to write, for example, 71 next to 4.8. Okay, you got to still maintain those ordered pairs. I'll give you a second to type all that good stuff in. Anybody need help entering in their data? Does that feel okay? Okay, so once I enter in the data, if I wanted to see this on a graph, if I graph this right now, I see 1 point. Okay. I know that my stat plot's turned on because I see 1 point. Okay, so I know that that's not the issue. I know it's okay. If I go to my second y equals, my stat plot's already turned on. That looks good. Okay. I need to adjust what? My window, right? You can do this using Zoom Stat. If you want your calculator to do it for you, it'll do the best it can. Okay, so you can see if I do Zoom Stat, which is number 9, I'm just typing in number 9, my calculator auto sets a window for me. It's pretty nice. It won't always work, so I don't want you to totally 100% rely on Zoom Stat. Your calculator is only a calculator, okay, but it will do the best it can. You can also manually adjust it by going to Window. So let's think about the lowest x value here. What is the lowest x value? 3, right? So your calculator chose a min of negative 36.9. Do you need it to be that low? No, okay? I mean, it can be. It gave us a nice picture, but if you chose something like 0, that would be fine as well, okay? Your x max, let's see, the maximum x value was 402, right? Your calculator chose 441.9. Well, maybe you only wanted it to go to 440. Like you wanted a nice number. You didn't want a decimal. Okay, you can make it 440. Maybe go up by 20s each time rather than 1. You'll see less tick marks that way. Okay. For y min, let's see, the lowest y value, I see 0.4. Is there anything lower than that? No? Okay, so your calculator chose negative 6.026. If you wanted to choose something nicer like 0, that would be fine. Okay, you don't have to go that low. And for your y max, let's see, what's my biggest y value? The 38.2. So your calculator chose 44.626. Maybe you only wanted to go up to 40. That's fine. Okay. Maybe you wanted to go up by 5 instead of 1. That's fine too. Okay. If I press graph now, it's just going to be a slightly more zoomed in version of that other graph. Okay. Does it look like it follows a linear trend? Yeah, for the most part. I mean, if I put my Papermate Flare pen down, you can see how it, most of the points, if I put my Papermate Flare pen over it, follow a linear trend. There are a couple of outliers though. Does everyone see these 2 points up here and then this 1 point over here? Okay, so there are a couple of outliers, but overall it looks linear. Okay, now let's go ahead and calculate what our regression equation is. Stat, calculate, and we said it looks like a linear regression, right? That's what the problem told us it was. I'm pulling my x values from L1, my y values from L2, and I want you to stop on where it says store regression equation. This is new. We are going to be pasting our regression equation directly into y equals to get the most exact graph we can. I used option 1 in high school. When I was in high school, we went to y equals after we calculated the regression equation, and we went to vars number 5 and chose the regression equation. I actually think it's easier to do option number 2. Before you even calculate the regression equation, go to this line, and we're going to do vars, y vars, and number 1. Okay, so at this line, I want you to hit on the vars button. So everyone see where vars is? Vars. I'm going to arrow over to y vars. I'm going to choose function. And you can pick where you want to paste it. So if you want to paste it into your y1, choose y1. If you want to paste it into your y2, choose y2. Right? Maybe you already have something in y1, so you want to paste it in y2. Okay? Just choose your location. I'm just going to do y1 for now. And I'm going to press calculate. So here's my regression equation. And you can see that if I go to y equals, see how now it's pasted into my y1? Woohoo! Pretty cool. Okay, so stat, calculate, linear regression, down, 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 bars, y bars, function, paste into my y1, press calculate. That's how fast it goes. Okay, so I want us to write down what we just got. So for part A, when I'm looking at my equation, I got y equals 0.0764x plus 4.9985. We'll stop there. Okay. And my R value, my correlation coefficient, is about 0.7. So makes sense it's positive because it's a positive slope. It isn't a number super close to 1 because we have those outliers. Okay. Now that I have my regression equation pasted in there, if I graph it, that's the line it's using currently. Okay. So I got part A. Part B was to just graph it. We did that. Interpret the graph in part B. We've already talked a little bit about the correlation coefficient and why, there's talked about how there's outliers. We know what our x values are, what our y values are. Okay, so we kind of already understand the interpretation. What I want you to do is I want you to identify the 3 countries that differ most from the linear model. Okay, so I'm going to go in my calculator to trace. I'm just going to press it once and see how now it's blinking on one of your data points. Okay. If you arrow left and right, it'll pop to different data points. Does everyone see how it's jumping? I want to identify my 3 outliers, so I want those 3 points. So I'm going to arrow over to the right until it lands on one of them. Okay. So like here, I'm on this one outlier, 184, 34.9. What country is that? Denmark, okay, 184, 34.9. That's Denmark. Okay, so I just wrote that down on my paper. Okay, I'm going to arrow over again till I get to another one. Okay, so another one is at 169, 38.2. 169, 38.2. What did you say it was? Japan. Thank you. Okay, and then I'll arrow over again until I get that last point. Okay, let's see. That's 402, 19.6. Canada. Okay, so those are my 3 outliers. I'm going to go back into my stat edit and I'm going to delete my outliers and recalculate my regression equation and see if I get a correlation coefficient that's closer to 1. Okay, so I'm going to go back to stat edit and I'm going to delete each of those. So if you're deleting individual entries, you just press the delete button. Make sure you delete both the x value and its corresponding y value. So for Denmark, I'm going to press delete on 184. And then I'm going to arrow over to the right, and I'm going to delete 34.9. Okay, so I deleted the x value and the y value for Denmark. Go to 169 for Japan. I'm going to delete 169, and then I'm going to arrow over to the right, and I'm going to delete 38.2. Then for Canada, I'm going to go down to 402. I'm going to press delete on 402 and delete on 19.6. Okay. So now that I've deleted those 3 outliers, let's calculate a new regression equation. Okay, so I'm going to go to Stat, Calculate, Linear Regression, Enter. I'm going to go down to Store Regression Equation. I'm going to hit my vars, y vars, function, and maybe this time I want to paste it into y2 so I could compare it with my original line, see how different it looks. Okay, I'll paste it into y2 this time just to see the difference. Okay, here's my new equation. y equals 0.0959, we'll say, x plus 1.0539. Okay, there's my new regression equation. Look at that R value. 0.92 now. I deleted my outliers, and now I have a correlation coefficient closer to 1. Right? That makes sense because it's going to be a stronger correlation. Go to your y equals. See how now you have an equation in y2? If I press graph, here was my original line, and then here's my new line. See how it's a little bit different? Everyone see that? It looks like that red line goes through that data a little bit better now that we've eliminated those outliers. Okay, so that was question D. It says delete the data for 3 countries and fit a linear model to the resulting data and give the correlation coefficient. We did that already. Let's theoretically say that I wanted to make a prediction when x was 32. How would I do that? Second calculate or second trace a value when x is 32, and I press enter. Right now, see how it says x is 32, gives me a y output of 7.4, but that's for my y1 equation, right? That was for my original regression equation. How do I get the prediction for my second regression equation in y2? Press the down arrow, and see how if I press the down arrow, then it pops to my red line, my y2 line. Now for the new regression equation when x was 32, y is 4.1. Look how different that is. Those predictions are totally different. Here when x was 32, y was 7.4. Here it's 4.1. Okay? All it took was eliminating those 3 outliers. Okay? So, any questions about that? How to use stat features? No?